N-hexane. When N-hexane has been treated with nitric acid, HNO3, one NO2 group replaces one hydrogen. So out of 14 hydrogen, one hydrogen will be replaced by NO2 and product water is formed. It is called nitrohexane. Nitrohexane. Suppose methane is treated. Methane is treated with nitric acid. As a result of that, one of the hydrogen will be replaced by, it is called nitromethane. Nitromethane. So it is called nitrohexane. The second compound is called nitromethane. So there are two methods of preparation, two types. One is alkyl halide with silver nitride and another one is direct nitration of alkanes. Nitric acid has been directly added with this. So these are the two forms. Now let's see the properties of nitromethanes. Actually, the nitroalkanes are colorless, pleasant smelling liquids. It has their own characteristic smell, pleasant smell, not like other compounds. For example, the acrolein, acrylic acid, acrolein. Acrolein has a very bad odor. Similarly, phosphine, you could have learned, it has a rotten fish odor, not like that. But nitroalkanes are not like other compounds having a pleasant smell. The nitroalkanes are soluble in water, while other members are sparingly soluble in water, but highly soluble in organic compounds. As I have told you, there are two tautomers exist in between this nitro compounds. One is called nitroform, another one is called acinitroform. This is acinitroform. This is called acinitroform. In acinitroform, one acidic hydrogen is there. Suppose it is treated with NaOH. It is treated with NaOH. The particular hydrogen could have been replaced by Na. Since it is in the form of acinitroform and having acidic hydrogen, the acidic hydrogen will be replaced by Na group. Actually, there is no proper bond between one and Na. There is the ionic combination between these two. It is called salt of nitrolic acid. Actually, it is also called a nitrolic acid. Here the speciality is nitrogen is positive and this is minus. It is positive. This is the original structure of this. In addition to that, water is formed. It is salt of nitrolic acid. So whenever nitrolic acid reacts with sodium hydroxide, the acidic hydrogen has been replaced by Na and you are getting salt of nitrolic acid. This is one case. This reaction is called neutralization reaction, of course. One acid reacts with base to form salt and water. It is called neutralization reaction. Suppose you are having a group like this, CH3CH2, N, arrow mark O and double bond O. It is one nitroalkane. Suppose it is treated with Br2 and NaOH. Bromine dissolved in NaOH. This carbon directly connected with nitrogen is called alpha carbon. Alpha carbon has two hydrogens. While reacting, one of the alpha hydrogen has been replaced by Br group. So you are getting alpha bromo nitroethane or monobromo nitroethane. It is called monobromo nitroethane. Monobromo nitroethane. When further it is treated with Br2 and NaOH. Further treated with Br2 and NaOH. Another hydrogen, this hydrogen, is also replaced by Br. Now you are getting dibromo nitroethane. You are getting dibromo nitroethane. So until all the alpha hydrogen have been removed by halogen, the reaction has been proceeded. This is one case. But it is different in the case of nitromethane. Let's consider nitromethane. When nitromethane is treated with a chlorine and NaOH, let's see what happened in this case. How many hydrogens are there? In methyl group, how many nitrogens are there? 3 hydrogens are there. All the hydrogen have been replaced by Cl group. So, you are getting CCl3NO2. And all the hydrogen, 3 hydrogen, have been released in the form of HCl. So, you are getting this compound. It is called chloropicrin. Chloropicrin. Actually, it is a trichloro compound. Trichloro nitromethane. Trichloro nitromethane. It is called trichloronitromethane. This chloropicrin used as a soil sterilizing agent. They are asking in one more question. The nitromethane used as a soil sterilizing agent. Then the next is called aldehydes and ketones. Now let's see how aldehydes are reacting with this. Suppose formaldehyde is there. When formaldehyde reacts with nitromethane, in the presence of dilute NaOH, you are getting CH2OH and CH2NO2. Basically, it is an ethanol. The NO2 is connected with second carbon. So it is called 2-nitroethanol. Suppose this is the aldehyde reaction. Formaldehyde reacts with nitromethane to form 2-nitroethanol. Shall we see the reduction of nitro compounds? When nitromethanes or nitroalkanes are reduced, you are getting the corresponding amines, methyl amines. For example, nitromethane. When it is reduced, in the presence of H. The reducing agents are tin and HCl. So obviously, the two oxygen have been replaced by hydrogen, and you are getting CH3NH2. It is called methylamine. Methylamine plus H2O. Methylamine is formed as the product, and you are getting 2H2O, and 6 hydrogen atoms have been employed here. So nitromethane upon reduction forms methylamine in the presence of tin and HCl. It is called reduction in acid medium. It is called reduction in acid medium. Because one acid is used, HCl is used. HCl is the acid. Suppose CH3, CH2NO2. It is nitromethane, and this one is nitroethane. When nitroethane is reduced in the presence of zinc and ammonium chloride, it is called neutral medium. It is called reduction in neutral medium. When the reduction takes place in the presence of neutral medium, ammonium chloride, a compound is formed like this: CH3, CH2, NH1 plus water. The CH3, CH2, NH1 is called ethyl hydroxyl amine. It is called ethyl hydroxyl amine. So these are the reductions. This is the reduction in acid medium, and this is the reduction in neutral medium. In the reduction in acid medium, nitromethane is converted into methylamine. Reduction in neutral medium, nitroethane is converted into ethyl hydroxyl amine. Now let's see what will happen when the nitro compounds are hydrolyzed. Nitroethane when nitroethane is treated with water and HCl, it breaks to form acetic acid, and NH2OH. So upon hydrolysis of nitroethane, it is nitroethane. Nitroethane upon acid hydrolysis forms acetic acid and hydroxyl amine. Hydrolysis of nitroalkanes gives acetic acid, that is one carboxylic acid, and hydroxyl amine. That's all about aliphatic nitro compounds.